Yes, good morning. We are the team in charge of Robotic that teaches sign language. My name is Raheem, Maliki.
Dalal,
Alright, first off, what are humanoid robots? Humanoid robots are like robots that have characteristics and resemblance to that of human. Now, robotics was, the term robotics was coined by Isaac Asimov back in the early 1941 to be precise, when he was creating the 3 robot laws for a movie. Now, examples of current humanoid robots, we have the Asimov, the Puppy, Now, and the InMove robots. All different current humanoid robots are available in the market. Now, our project description was basically to design a humanoid eye that's able to teach children sign language. Now, this eye should be able to teach letters, words, and short sentences to enable the children to converse amongst themselves. Now, this project is going to improve the children's enthusiasm towards learning in the classroom, and also reduce overstimulation in children in classroom, as this is a current issue around the globe where it comes to teaching children. Also, this project can be used by adults, not just children alike, who want to improve on the sign language which they know already, or they want to reinforce what they already know. To give you an idea of what their hand should be able to, just the hand should be able to do, we have letters in the sign language. But this hand will be able to teach more than just the letters. We're trying to have the hand actually teach words, and to teach words we need more than just the hands. So we're going to have the arms as well as part of the design. Now, similar projects, right now we have the communication Android by Toshiba. Now, this Android is able to actually converse using sign language, Japanese sign language to be precise. Now, this can converse, but it doesn't teach, meaning it doesn't actually give feedback or anything like that. And we also have the Now by SoftBank. Now, this is actually currently implemented in several classrooms around the world. Now, what Now has done is basically they've given programmers the opportunity to develop softwares for these robots. That an example of such a software is called Touch My Head, in which the robot asks kids to touch the head, and once they do this, it congratulates the children. Now, this is something we're leaning towards, an interactive means for children to learn in the classroom. So this is something where this is an approach which we're trying to use in this project.
As far as design constraints, we want the robot to have all human-like motion, since we are trying to teach sign language. Also, we want the robot to perform all the signs in a timely manner, because there is no point to build a robot that signs and takes forever to do each sign, because we're trying to build a composition and it has to be done in a timely manner. Also, we need the arm to have 7 degrees of freedom. We'll achieve that by having a cylindrical joint in the shoulder, spherical joint, revolute joint in the elbow, cylindrical joint in the wrist, as well as 5 revolute joints for the fingers. And finally, the arm should be cost effective.
For the design overview, we had 3 different approaches. The first approach, to buy a robotic hand, which is the most expensive option. The second approach, to design from scratch a robotic hand, which is more logical option, but as a time constraint, one of the factors we needed to be considered, we cannot go by this option. The last approach is using open source platform, which is allow us to work with a professional design, and it's more efficient.
Our team decided to go with the open source design. We found 3 available options. The first one is the Puppy project. We can't go with that one since the hand and fingers can't move. And if we decide to modify the design of the hand, we will encounter another issue of having enough space in the forearm for the actuators to move the hand and fingers. The second one is the iCup. We can't go with that one since it costs for the robot $270,000. The third one is the InMove robot. For the InMove robot, we can take the robot apart and just use the parts that we need. And we decided to go with the InMove robot since it matches all criteria and do all the requirements that we want.
For the global learning aspects, use universal symbols such as INO for nano switch. Use universal units such as SI and US customer units. provide multilingual user manual. For example, our group speaks 2 languages, Arabic and English, so at least we will provide these user manual these 2 languages. Use an open source sector.
Alright, since this design isn't like, we're not designing anything, so this design is basically more on the coding and more like on the coding side of engineering. Now, for the coding part, we'll be using Arduino Mega. When it came to like deciding either Arduino or Raspberry Pi at the point, we decided to go with Arduino because it's more friendly towards our students, cost-wise as well. Also, we'll be using electric actuators because right now we're trying to go for speed. Like Khalid said earlier, this is more towards speed rather than like lifting. So like all the actuators need to be fast in order to like sign in a proper and timely manner. Also, we're programming with Python because right now I know collectively we all have background in C++, Java, and C. But we decided to use Python because Python is like more commonly used with Arduino. And also from the InMove website, the background for the InMove robot was those are the 2 platforms they used together. And also we're printing with ABS plastic, thanks to its heat tolerance, and also it's a lot stronger than the counter PLS plastic.
Since we're using the related standards for our project, we have 4 main related standards, which is the ISO, NSI, IFR, and the ASL standards. Because we have a new aspect of robotics. There is robotics which form sign language, but there's no robotics for teaching sign language. So we're getting our based on the IFR standards, and the teaching the ASL standards. There is some teaching ways of using the hands for the children. And as you see, the ISO standards, we have the vocabulary for the mobile robots and the coordination system for the motion workers and the safety requirements for the personal care robots. As we don't want the children to interact with the robot side. And the NSI standards, we have the industrial robots and robotic systems safety requirements. So it could fit all requirements for all classes in the US. So it could match. And the projected timeline, since we are in November, we have the conceptual design, and we just finished it and going through the SolidWorks for printing and design and assembly.
Now we do not want this program just to end there. So for future work, we actually want this robot to be able to like correct, not just teach, but also correct the kids when they're signing. So to do this, we find that Arduino, one of the reasons why we picked it, we can actually create a virtual network where it's able to actually perceive the surrounding areas, so that when the kids wear some certain glove or certain things and they sign, the robot can actually correct them based on what they've done, if they've done it right, if they've done it wrong. Also, right now, we want to also give the option to select a preferred language, because right now coding ASL by itself is going to be a strenuous task. But for future, we want to like actually look into like coding more languages as far, because right now sign languages isn't just limited to the US. So there is like sign languages all around the world. We have BSL, JPL, and other sign languages around the world. So we want to give the users an option to select whichever sign language they want. And also, we'd like to collaborate with the face team, because right now sign language isn't limited to just moving the arms about. We actually need some facial expressions as well to like properly convey feelings, to properly convey what the user is trying to like denote or pass across. And with that, we open the floor for questions.
So the actual robot design is open source?
Yes, sir.
And have you started to build it?
Right now, no, we haven't set up to build it. We're currently looking for the cheapest place like to print out all the parts, and we found somewhere, and we were putting in the order momentarily.
Okay, because this ends up being a coding project, is what I think. So you need a lot of time for that.
Yes,
I would assume.
yes, that's one of the reasons, because like we need to be able to move all the arms around. That's one of the reasons why we decided to go with the open source instead of designing from scratch, because then we wouldn't have enough time to like properly like run all the simulations on the end, then to start coding, because coding is going to take up most of the time.
Just make sure you design safe, so you don't get hurt with the robot.
Yes, that's going to be one of our criteria. Yes, sir.
You're using open source, but you're printing everything and like all the mechanisms with the fingers and stuff. Have you guys done any analysis on that? Like if your motors can actually handle the load of like driving, what a 1 foot long bar to close a finger and stuff like that? Like, is that, because I mean, if your power draws not enough.
Yes. Based on that, like we looked at the average weight of each one of the parts, we combined them, and we looked at different actuators. And right now, the actuators we've currently selected for the shoulders, which is going to be the one lifting the most weight. It can lift the combined weight of the arm plus an extra 5 pounds. So I think we're way. Yes, sir.
Have you talked to the other team doing the eye surgery, trying to convince them to work this with you? Have the face and the arms working collectively rather than 2 different projects?
No, we have not talked to them yet, because right now it's like this is still a very big project for us. So we haven't tried to like bring them in, because we don't really want to give them our headaches, or basically we don't want any conflicts within the teams right now. So we want to like actually have the design. Once the design is up and up, then we can like tell them this is what we have. Would you guys like to come and join us? Because right now this is still a conceptual design, so we haven't actually started printing. Like I said earlier, we're just about to like start printing and assembling it. So once we have the irons up and running, then we'll like invite them to like see if it's something like they would like to like have or collaborate with us in.
Are you designing this in series? So you're going to do the manufacturing first, and then the coding, and then the testing?
Yes.
I would urge you to consider doing the manufacturing and the coding in parallel. As you pointed out earlier, it looks like a very tedious and time-consuming project, where maybe you can split off a little bit of or take turns. One person doing the coding some weeks, and then the others doing the manufacturing. Try and move both at the same time, because if you have issues with manufacturing, then you're delaying your coding. If you have issues with the coding, and you left it all the way to the end, now you're gonna be short on time. This way, if one of them has issues, at least the other one is progressing.
Thank you very much for taking note of that.
How do you plan on testing your code?
Right now, I think we're going to like create a virtual network or virtual network to like basically just run the codes and see if it actually moves. If it moves, then we're going to like transfer them to the real listen and hopefully drives over. But right now, yes, busy.
So you're saying that you're not going to test it, so you have you'll test it in like a hardware out of the loop state, and then once you're ready with hardware, you're going to start testing your software on the actual arms. Is what you're saying?
Sorry, I don't get.
So like you're saying you're going to test in a virtual environment.
Yes.
And then once you test that, you're going to implement it onto the hardware.
Yes, that was our plan, but right now, that was our initial plan. But right now, what you just said right now, as far as like coding and printing at the same time, so we're going to be looking more into like probably combining them right now, because that seems like more of a logical standpoint, as far as time, because we're looking to actually like code and build as 2 separate things. So we're like looking into combining the 2 of them right now.
Have you considered testing like a small portion of your mechanism?
Yes, we have.
You're like testing in virtual environments, because in my experience, hardware does not work the way you expect it to work.
Yes, we have. We actually printed out a finger, which we're able to move. Thank you very much.
Thank you.